Welcome to MrCScience.com's video on scientific notation. Scientific notation is a way we deal with very large and very small numbers so we can easily relate them to each other and multiply and divide them by each other. We'll show why in just a second. So let's start with some big numbers. I was out and about yesterday, so I thought, hey, I'll take a picture of the Earth and the Sun at the same time and show the distance between them. It's a very good picture and obviously very accurate. Okay, so what we're going to do is we're going to talk about the distance between the Earth and the Sun. The average distance between the Earth and the Sun, the scientists label as 1. Whoops, grab my pen. 1 astronomical unit, or 1 AU. That's a unit of measurement we use for measuring stuff in our local solar system area. 1 AU. 1 AU is equal to just under 150 million kilometers. So if we want to work with this number 150 million, it's large and kind of unwieldy. We can fit it in our calculator, but if we multiply it by anything, the answer is going to be hard to get off our calculator. So we're going to convert it to scientific notation. So when you do scientific notation, the first thing you do is you grab the significant figures. If you're not familiar with significant figures, go ahead and watch my significant figure video. So our significant figures here are 1, 5, 15. Now we place the decimal place after the first significant figure. So we only have one significant figure in front of the decimal place. This should never be a 0 because 0 on that side of the decimal place is not significant. So then we take it and we multiply it by 10 to the power of how many places we had to move the decimal place. So we moved it to here, so we had to move it 1, 2, 3, 4, 5, 6, 7, 8. 1.5 times 10 to the 8th kilometers equals 150 million kilometers. Let's try another big number like that. So let's take 217 0. Let's make it a really big number. Let's see what we got. Thousand, millionth, billionths, trillionths, quadrillions, quintillions. So 21 quintillion, 700 quadrillion. So let's convert this to scientific notation. So we take our significant figures, our 217. We put the decimal place after the first significant figure, so only one significant figure is to the left of that decimal place, and it's not a 0. Then we multiply it by 10 and we take how many places we had to move to get the decimal place there. I did mention it before, the implied decimal place is right there at the beginning, so we had to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 places. So this number is the same as 2.17 times 10 to the 19th. Okay, let's deal with very small numbers. The width of one human hair is considered, there's average, it gets thin and thick, but an average for a human hair is about 75, oops, my 7 minutes, there we go, 75 microns. Okay, 1 micron equals 1/1,000,000th of a meter, or 0.0000001 meters. So 75 microns equals 0.00000, oops, Control Z. Only 4 zeros because we got the 75. 75 times this is 0.0000075 meters. Okay, so how do we write this in scientific notation? So start with your significant figures, our 75. Put the decimal place to the right of the first significant figure. Then multiply it by 10 to the power of what we moved the decimal place. This time we're going the other direction, so we're going to put a negative in front of our exponent. So we moved it here. So we moved it 1, 2, 3, 4, 5 places to the right. Meters. So 0.000075 meters is the same as 7.5 times 10 to the negative fifth meters. Let's do another quick small number just to get the idea. Let's go even smaller. 0.00. I'm going to make this point out something else here too. So let's just do some zeros while I'm talking here. I have no idea how many are here. We're going subatomic here if we go meters, but okay, and let's just put 5. Okay, so this number is too long to put in your calculator, first of all, so that causes a problem right there. So let's convert it to scientific notation. Now this time we only have one significant figure, 5. So we put the decimal place to the right of that significant figure. Since there is no other significant figure here, the decimal place is implied. We don't actually physically put it there. Then we multiply it by 10. We're going the other direction, so the exponent is going to be negative. And we moved it, we went all the way to here for that. Oh, don't draw a circle. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 5 times 10 to the negative 19. So that's a very small number. Okay, so let's now deal with how we work with these small numbers on our calculators. So this allows us to work with very big and very small numbers. Okay, so let's deal with two very big numbers. So let's go average, or let's just pick two numbers. 2, 5, 0. Oh, come on. 0, 0, 0, 0, 0. So 2,500,000 times another large number, 1,500,000,000,000,000. So we're going to take 2,500,000 multiplied by 1,500,000,000. So this may not even fit on your calculator, so you could write it out by hand. You could go, okay, 1, 5, 1, 2, 3, 4, 5, 6, 7, 8 times 0, 0, 0, 0, 0, 5, 2. You can multiply those together and deal with all your zeros and fun stuff like that. Or we can convert it to scientific notation and do a much easier way. So let's start converting 2,500,000 to scientific notation. Take our significant figures, 2, 5, put the decimal place to the right of the first significant figure, and then see how many places we had to move that decimal place. 1, 2, 3, 4, 5, 6 times 10 to the 6th. And I blew it again because I didn't deal with it. No, I did. Sorry, I'm going to leave that for right now. Times 10 to the 6th. Now we're going to multiply it by the other one. 15 is our significant figures. 1, 5, put the decimal place to the right of the first significant figure. Times 10 to we moved the decimal place from there to there. So 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the 9th. So what we can do here is we can deal with first our numbers. 2.5 times 1.5. Might be able to do this in our head, but since we're in science class, we can use calculators. So I'm going to do 2.5 times 1.5 equals 3.75. Now significant figures. We have two significant figures here, two significant figures here. We should report our answer in two significant figures. So that rounds up to 3.8. So 2.5 times 1.5 is 3.8. Now let's deal with our exponents. So we're going to multiply our exponents together. We're going to take our 10 to the 6th times 10 to the 9th. Now when you multiply exponents, if you haven't covered this in math yet, you just add their exponents. We're going to have 10 to the power of 6 plus 9, or 10 to the power of 15. So our answer here is 3.8 times 10 to the 15th power. Make sense? Okay, let's try another one. This time let's work with some very small numbers. So let's go 0. That looks 0.00005 times 0.0000007. Okay. So again, hard to put this in your calculator. You can. The answer may come back in scientific notation anyway, so you need to know it. So let's convert this to scientific notation. We got our 5 as our significant figure. Decimal place to the right of the first significant figure. Since it's all by its lonesome, we don't put it there. So times 10. This time we're moving the decimal place the opposite direction, so it's going to be negative. Move from there to there. So 1, 2, 3, 4, 5, 6. We went -6 times our next one, 7, again all by its lonesome, implied decimal, times 10 to the negative, and we moved it there. So 1, 2, 3, 4, 5, 6, 7, 8. -8. Okay. So this will give us an interesting opportunity to show you a little something that happens sometimes as well. So 5 times 7. Let's deal with our numbers first. That one you should know is 35. Now let's do our decimal places, or our exponents. 10 to the -6 times 10 to the -8. Again, that's just adding them together. So we got -6 plus -8, or -6 minus 8, which is -14. So we got 35 times 10 to the -14th power. Now this is not our answer. If you put this on your test or something, I will mark it partially wrong, because scientific notation should have a decimal place after the first one. So in order to do that, we got to move that decimal place. So it's going to be 3.5 as our significant figures, and now what we had to do is we had to move the decimal place one to the right. So that 35 is the same as 35 times 3.5 times 10 to the first power. But we also have it times 10 to the -14th power. So we had to move it. So now when we multiply tens, again, we add their exponents. 1 plus -14, or 1 minus 14, is -13. So our real answer is 3.5 times 10 to -13th. Don't be afraid to play that back to understand what happens when we have to move the decimal place on our answer. Let's do another one. This time what we're going to do is we're going to divide our numbers. So let's take a large number, let's say 7,830,000,000. Yeah, that's right. Divided by 64 million. Okay. So again, let's convert them to scientific notation. Significant figures here are 783, decimal place to the right of the first significant figure. We moved the decimal place from here to here. So we went 1, 2, 3, 4, 5, 6, 7, 8, 9. So we did times 10 to the 9th power. We're dividing that by 64 million. Scientific notation, 64, the significant figures. Decimal place to the right, times 10 to the, we moved the decimal place from here to here. So we went 1, 2, 3, 4, 5, 6, 7, 10 to the 7th. So first of all, let's deal with the numbers. So we're going to take 7.83 divided by 6.4. Again, this is science class. We get to use calculators. So let's go with 7.83 divided by 6.4 equals 1.2234375. Well, let's deal with significant figures again. This has 3 significant figures. This has 2, so we're reporting our smallest significant figures, which is 2, so our answer is going to be 1.2. Yeah, come on. Okay, now let's deal with our exponents. We got 10 to the 9th divided by 10 to the 7th. Now when you divide, when you multiply, you add it. When you divide, you subtract. So this is the same as 10 times 9 minus 10 to the 9 minus 7th power, or 10 to the third power. No, second. Simple math is hard. Okay, 10 to the second. Anytime you have a 1 or a 2 here, I'll usually just bring it back out. So what's 1.2 times 10 to the second? Well, 10 to the second moves the decimal place twice. So our answer is 120. Cool, makes sense. Let's do a division of ultra small numbers. Okay, let's take some very small numbers. I'm just going to make some stuff up, so we'll see if we get something interesting. 649 divided by 0.00000. I'm going to do this a little bit differently. 75. Okay, so let's convert these to scientific notation. 649 decimal place to the right of the first significant figure times 10. We're going backwards this time, so it's going to be a negative exponent. We're going from here to here. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 6.49 times 10 to the negative 10th. Divided by our significant figures, 7, 5. Put the decimal to the right. So we're going to move the decimal here. We're going to move it 1, 2, 3, 4, 5, 6. We're going negative, so it's going to be to the negative 6th power. Okay, deal with your numeric numbers in front first. So 6.49 divided by 7.5. Let's use our calculator. That's definitely not one I could do in my head. 7.5 equals 0.865333333. Okay, so 3 significant figures, 2 significant figures, so we're going to report it in 2 significant figures. 0.865 rounds up to 0.87, so our answer is 0.8. 0.87. Now let's deal with our exponents. We got 10 to the negative 10th divided by 10 to the negative 6th. So that's the same as subtracting it. So it's 10 to the negative 10th minus negative 6th. Minus is plus, same as negative 10 plus 6, or our answer is times 10 to the negative 4th power. Okay, again, this answer, while being correct, isn't absolutely correct. I would give you partial credit because of where this decimal place lives. It should be here. So we need to move it there, 8.7. When we move it there, we're moving it backwards one place. So we have 10 to the negative 1st. Then we bring in our times 10 to the negative 4th. We multiply these together, so we add them. So negative 1 plus negative 4 is negative 5. Our answer is 8.7 times 10 to the negative 5th. So hopefully that makes sense for you. Feel free to watch the video again. If it still isn't connecting, don't be afraid to contact me at Mr. C at MrCScience.com.